Hello everyone. In this video, we are going to discuss about overview of convolution neural network. Initially, I would like to explain why we go for convolution neural network. Convolution neural network is a special type of deep learning model mainly used to process and analyze images and visual data. It is inspired by how the human brain and eyes work together to recognize patterns and objects. CNNs are designed to automatically extract important features from images such as edges, colors, textures, and shapes without the need for manual feature selection. It also plays an important role in various tasks such as image classification, object detection, and natural language processing. In order to achieve better feature extraction, we usually use convolution neural network. So these are the primary goals of learning convolution neural networks. Now I am going to explain about the simple CNN architecture. CNNs have been made up of many different layers. These layers include the input layer where the image goes in, then convolution layer which looks for patterns like edges or shapes. Then we have pooling layer which makes the image smaller and easier to handle. Finally, we have fully connected layer which makes the final decision like recognizing if the image is a cat or a dog. Now let's discuss more about CNNs in detail. Initially, it has input layer. This is the layer in which we give input to our model. In CNN, generally the input will be an image or a sequence of images. Usually an image represented as a matrix of pixel values. If the image is a black and white or grayscale image, it is a two-dimensional table. Just height and width. And it can be represented as a matrix of 28 cross 28 pixel values. If the image is in color, then it has three parts: red, green, and blue. So it is a three-dimensional table. Just height, width, and color channels. And it can be represented as a matrix of 28 cross 3 pixel values. Now let's see how CNN recognizes an image. Let's use this smiley face diagram to understand how a convolution neural network recognizes an image. This is a simple smiley face drawn with curves and lines. Generally, humans can easily notice the smile, eyes, and nose, but a computer doesn't see pictures like we do. It sees only numbers. Here, image is represented in the form of shaded and unshaded pixels. The shaded squares shows the parts of the shape like eyes, nose, and smile. The unshaded squares are just the background. After that, image is represented in the form of matrix of numbers. Here you can write shaded parts as 1, and unshaded parts as 0. So in this way, the input layer takes the image, changes it into pixel values, and sends to the next layers to find important features. The next part of the CNN architecture is convolution layer. This is the layer where actual convolution operation is performed. This is the only layer where the feature extraction is performed from the input data set. So how the feature extraction is performed here? Convolution layer of CNN has two important key terms, that is kernel and strides. The kernel is also called a filter. Kernel is a small square matrix, usually 2 cross 2, 3 cross 3 or 5 cross 5 shape that slides over the image to detect patterns like edges, lines or textures and compute the dot product between the kernel weight and corresponding input image patch. The output of this layer is termed as feature map. Another one important thing is stride. Stride is how many steps the kernel moves at a time as it slides over the image. If stride size is 1, then kernel moves 1 step at a time. If stride size is 2, then the kernel moves 2 steps at a time. Then after each convolution operation, an activation function is applied to make the network nonlinearity. ReLU is the commonly used activation function in the convolution operation. This enables the network to learn more complex patterns. After nonlinear activation function, we have pooling layer. The main purpose of using the pooling layer is to reduce the dimensions of feature map, which is received from the previous layer activation function. We have two types of pooling strategies. They are max pooling and average pooling. Max pooling select the maximum value from each patch, emphasizing the most prominent features. Then average pooling computes the average value in each patch, providing a smoother representation. Generally, pooling layer reduces the computational complexity and helps prevent overfitting by reducing the sensitivity of the output to small translation in the input. After that, we have fully connected layer. It is also called as dense layer. After several convolution and pooling layer, the data is flattened or turned into a single vector. This vector is sent to one or more fully connected layers. These layers combine all the features and make the final prediction. For example, deciding whether an image is a cat or dog. Finally, we have output layer. It gives the final result. For classification task, it usually uses a softmax function that gives the probability of each class. For example, 90% cat and 10% dog. Let's walk through a simple example of a CNN layer flow step by step. We'll start with a small 4 cross 4 image. This is the corresponding input matrix. And let's take a 2 cross 2 filters here. Then stride size is 1, no padding. How it works? First, take the input matrix. Then place the filter on the top left corner of the input matrix. Then multiply each number in the filter with the corresponding number in the input. Then add all the results to get one number. Then slide the filter to the right and down and repeat the process. This gives you a new smaller matrix called the feature map. So what is the first step? First we need to place the kernel on top left corner of the input matrix. We can place the kernel like this and we can write the filter values 1, 0, 0, minus 1 here. Then what is the next step? Do the dot product and sum up them together. So the result from these will be stored in the feature map. So we can do the dot product 1 cross 1 plus 2 cross 0 plus 4 cross 0 plus 5 cross minus 1. The result will be minus 4. So this result will be stored in the feature map. Then we can shift the kernel to right by 1 pixel position since stride size is 1. Then do the same dot product, sum up them, and result will be stored in the feature map. So next we can place the filter. We can place the filter here and write the filter values 0, minus 1. Then we can do the dot product 2 multiplied by 1 plus 0 cross 0 plus 5 cross 0 plus 6 cross minus 1. So the result will be minus 4. So this result will be stored in the feature map. Then we can shift the kernel to right by 1 pixel position. Then do the same dot product, sum up them, and result will be stored in the feature map. So now we can place the filter here and write the filter value and do the dot product 0 cross 1 plus 1 cross 0 plus 6 cross 0 plus 2 cross minus 1. So the result will be plus 2. This will be stored in the feature map. Now the kernel reaches rightmost position. So we can shift the filter 1 step down and then do the same dot product and result will be stored in the feature map. So we can place the filter here and do the dot product. Then the result minus 4 will be stored here. Then we can shift the kernel to right by 1 pixel position so that we can place the filter here. We can place the filter here. Then the result minus 4 will be stored here. Then we can shift the kernel to right by 1 pixel position. So we can place the filter here. Then the result 3 will be stored here. So now also the kernel reaches rightmost position so that we can shift the kernel 1 step down. So we can place the kernel here. Then the result 4 will be stored in the feature map. Then we can shift the kernel to right by 1 pixel position so that we can place the kernel here. Then the result 6 will be stored here. Then finally we can place the filter here. Then the result 9 will be stored in the feature map. So this is the final feature map. So after performing the convolution operation, the next step is usually apply the ReLU activation function to the output feature map. In order to perform ReLU function, we need to take each value in the feature map and then apply ReLU activation function. If the value is greater than 0, keep it. If the value is less than or equal to 0, replace with 0. Then we can get the final activated feature map. So here, this is our feature map. Here the first value is minus 4, so that it is replaced with 0. Second value also minus 4, it is replaced with 0. Third value is plus 2, so you can write 2 here. Then next value is minus 4, it is replaced with 0. Then minus 4 replaced with 0. Then plus 3, write 3 here. Then plus 4, write 4. Then you can write 6 and 9. So this is the final activated feature map. So this is now passed to the next layer. For example, pooling layer or another convolutional layer. So next to move on to pooling operation. So here I have taken the same activated feature map, and I am going to use same filter, 2 cross 2 filter, and stride size is 1. So I am going to apply a 2 cross 2 maximum pooling to the ReLU output feature map here. Actually, our initial input matrix has a size of 4 cross 4 matrix. After applying the convolution operation with a stride of 1, the output size reduces to 3 cross 3 feature map. Next, we apply a pooling operation which will further reduce the dimension of the matrix. So, first I am going to apply the filter here and pick the maximum value. Here the maximum value is 0. This will be stored in the pooled output. Then apply the filter here. Then take the maximum value 3. This will be stored here. Then apply the filter on this region. Then take the maximum value 6 will be stored here. Then finally apply the filter here. Then take the maximum value 9. This will be stored here. So this is the final pooled output. So after applying the pooling operation, the dimensions further reduce to a 2 cross 2 matrix. So now let's move on to flatten layer. The flatten layer is used in neural network to convert multidimensional feature maps into one-dimensional vector, so that it can be fed into fully connected layer. So here the flatten layer going to convert our two-dimensional pooled output into one-dimensional vector. So the corresponding one-dimensional vector will be 0, 3, 6, 9. Then this one-dimensional vector can be fed into fully connected layer. Fully connected layer is the final stage in a convolutional neural network used for classification or prediction. Then softmax is an activation function used in the final layer of the classification neural network, especially for multi-class classification. It converts raw scores into probabilities. So the outputs are between 0 and 1 or sum up to 1. So next let's see about the softmax operation. Softmax operation converts the flattened pooled output into corresponding class probabilities. So this is our flattened pooled output 0, 3, 6, 9. Then this is the softmax formula for converting the flattened pooled output into class probabilities. So here we need to find the value of e power 0, e power 3, e power 6 and e power 9. Then substitute those values on the softmax activation function, and we will be getting the final class probabilities. So now let's find the e power value of flattened pooled output. E power 0 is 1, e power 3 is 20.09, e power 6 is 403.43, e power 9 is 8103.08. So sum of them together will be getting 8527.6. So now we can apply those values in the softmax output formula. So after applying those value, it become 1 divided by 8527.6, then 20.09 divided by 8527.6, then 403.43 divided by 8527.6, then 8103.08 divided by this one. Then this will be converted into corresponding probability values, that is 0.0001, 0.0024, 0.473, 0.9502. So this belongs to class 1, then this is class 2, class 3, class 4. This means the model is very confident, 95% in class 4 based on this input. So in this way, the CNN takes the input image, converts it into pixel values, applies the convolution operation, ReLU operation, pooling operation, softmax operations, and finally produces the prediction result. I hope you found this video very useful. Thank you for watching.